All right. Chapter 8, A Model of the Universe. We have arrived at a point at which we should start putting all the ideas mentioned before into a consistent framework or model of the universe. We have to show how instant communication is possible in our universe. We have to show how instant communication is possible in our universe. We have to show that all knowledge is already here and available. We have to show how all the different levels of consciousness fit into our proposed model of the universe. And last but not least, we should be able to show that within our present physical universe, we can find structures corresponding to our model, which would justly justify the rule postulated earlier, as above, so below. In other words, we should be able to see somewhere within our visible universe a physical structure that would be a small-scale model of the larger universe we are postulating. First, let us look at the model of the universe currently in favor in the scientific community. It is the Friedman-Gamow general astrophysical model of the Big Bang universe. The Big Bang. This is how it works. At some time long ago, all matter in the universe was located in one compact, very hot ball having an enormous density. It was a kind of cosmic egg with all matter and space contained in it. There existed nothing but this primeval fireball. Then somehow this egg got the urge to expand or explode and did so. This explosion, the Big Bang, was supposed to have been everywhere, concentric and uniform, which means that matter together with space started expanding evenly in all directions. At first, matter was in the form of very high temperature, high frequency radiation, and as it expanded, it eventually cooled to a point at which larger stable components of matter began to appear. These were the first elementary particles of our familiar solid matter, the neutrons, the electrons, and the protons. Later, the simple elements were formed out of this soup of hot primordial particles. Hydrogen and helium atoms were formed. These produced huge clouds or nebula, which started breaking up into smaller units. These, in turn, continue condensing due to their own gravitational pull, thus forming the basis for the evolving galaxies. The clouds of matter within these nebulae became more and more compact, which caused a rise in temperature of their centers. The first protostars appeared in the form of blobs or glowing hydrogen gas. In time, very high temperatures were reached inside their cores. These temperatures kept rising until nuclear reactions were eventually achieved. The nuclear reactions produced much heat and light, thus the first heavenly bodies, similar to our sun, were born. In the core of these stars, heavier elements were being cooked, and eventually a variety of elements that make up our present physical bodies were synthesized in the stars. It should make us proud to know that the elements composing our bodies were made in these great radiant stars. Another aspect of the Big Bang theory is the assumption that since the time of the Big Bang explosion, all matter has been distributed as if on the surface of an ever-expanding balloon. This surface is growing, and therefore all islands of matter that we call galaxies have ever since been running away from each other. We can see it happening today when we look at the distant galaxies. All the distant galaxies that we see through our telescopes are running away from the Milky Way galaxy and from each other. It means that the volume of our universe is constantly increasing, and that this is why we call it the expanding universe. Whether this expanding universe eventually reverses itself, starts collapsing, and ends up as it was before, one big glowing hot blob of matter, has not yet been decided by the scientists. Naturally, the idea of such a pulsating universe would be aesthetically more satisfying than a one-shot universe. All the processes in the universe seem to be cyclic, and it would be most unlikely that the largest process of them all would not be so. The smaller process should mirror the large one. This, at least, is our belief. The continuous Big Bang universe. One of the obvious results of a concentric and uniform Big Bang, as we have described it, would be the homogeneity and isotropy of the expanding universe. However, some measurements seem to show a bit of anisotropy, or unevenness involved in the expanding universe. This is possibly suggested by the distribution of the so-called quasars. Quasars Quasi-stellar objects. Quasars are very distant and unusual galaxies. They are compact and star-like, emitting tremendous amounts of energy in radio waves and visible light. There are as yet no sufficient explanations for the amount of energy emitted by the quasars. They emit about 1,000 times as much energy as a regular galaxy and behave in other unusual ways. They fluctuate greatly in brightness within a few days and in general are misbehaving and enigmatic objects. Sometimes when such a quasar happens to be disposed to us at the right angle, we can see in its portrait an unusual feature. That is a photo of quasar 3C 273, plate 1. A luminous jet of matter issuing from its center, figure 37. This jet clearly is a beam of matter ejected from its center of the quasar due to some pressure buildup inside it. What we see here is an explosion of a different kind from that of the Big Bang. It is a controlled non-concentric explosion. Let us try to visualize what is happening here. Suppose that we have a ball of very hot, dense matter floating in space. It stands to reason that due to energy radiation from its surface, the outside surface or skin of the ball will be cooler than its center and therefore possibly more viscous. Let us suppose that the pressure inside this ball grows to a point at which it is about to explode. The chances are that the surface of the ball will always have a weak point at some place, and as the pressure grows, it is this weak spot that will sooner or later burst and allow a jet of matter to squirt out. As this happens, an equilibrium will eventually be set up between the pressure buildup inside the sphere and the amount of matter that escapes through the hole in the skin. What we have now is a situation similar to that of a rubber balloon filled with air and pricked with a needle. The air will escape and the balloon will slowly deflate. If we take this model and say, well, why couldn't we have the big original cosmic egg behave this way? The answer is that it may very well have done just that. Let us consider one more clue that reinforces our assumption of the more viscous skin of the surface of the original body. It is that no counterjet is visible on the opposing side of the quasar. See plate 1. We know that the reaction to a mass being ejected from one side of such a body will tend to cause a counterjet of equal size to appear on the other side of it. However, this is not the case in the observed quasars. The counterjet is not visible because its energy may have been absorbed by the more viscous and elastic surface of this body on the side opposite to the jet. The idea that the nuclei of galaxies are chipped off the old block is not new. It has been mentioned lately by the Russian astronomer Ambart Sumian, who in the past has been shown to have had very good intuitive insights concerning matters that, in spite of general disbelief, were later found to be correct. He suggests that the nuclei of galaxies existed from the very beginning, possibly as fragments remaining from the original Big Bang, and we shall use this line of thought to develop our model of the universe.